Hello, everyone. How are you doing, guys? How is your day?
Hello, nice to meet you.
Nice to meet you. No, well, nice to see you. We already meet last previous time. So, yeah. Do you have anyone new today? Anyone who didn't introduce himself, his or herself? No? Okay. Well, I think we can start. If there is anyone will add, they will add. So let's let's summarize. So today, actually, a lecture. It will be either one, either two. I don't know how long it will take. So we will see. But it will include a few points. The agenda will be a first industrial revolution, second, third, and fourth industrial revolution. And probably in a different class, we're also going to talk about fifth industrial revolution, what is digitalization, and goals for Ukraine that I found by this year, which is quite interesting, those goals that would be mentioned. Also, in general, the topic about today, it's the evolution of industrial revolutions from Industry 1 to 5.0, their impact of sustainable economies. And I actually want to ask you, do you guys know, are we right now in a industrial revolution number 5 or at 4? Who could answer this question? Who can? Any ideas, just guesses? Or maybe we don't know what industrial revolution is. No? No ideas? Okay. Well, then I'll ask this question later on when we will get to the Industrial Revolution point 5. All right. And let's start also by summarizing a previous lecture. We talked about sustainability and the sustainable development goals that we can use toward our business or toward our city. And I just want to give you a short 4-minute video about sustainable city future of Copenhagen, which is a great example because, as I mentioned also in a previous lecture, they implemented so many strategies that are given a very good solution and benefits for now.
Cities all over the world are bursting with people. More than half of us live in cities now, and by 2050, that number jumps to nearly 70%. That's a lot of people. So how do we grow cities sustainably? And with the climate crisis, figuring out how we do that is more important than ever before. But there's one city that may be doing it better than any other place on Earth.
We want to become the first carbon neutral capital city by 2025.
So we packed up our gear and headed here to Copenhagen, Denmark to find out how. It's not surprising to learn that 2/3 of the world's carbon emissions come from cities. That number is getting worse as more of us move into cities, which means a higher demand on infrastructure and resources. So Copenhagen is on a mission to cancel out all of their carbon emissions.
My name is Frank Jensen. I'm the Lord Mayor of Copenhagen. When I became mayor, we started this process. We decided that we would want to become the first carbon neutral capital city by 2025.
What does carbon neutrality actually mean? For a city, it's creating more renewable energy than the dirty energy it uses. It's all about achieving a net zero. And their plan is focusing on mobility, pollution, and energy.
We have introduced a lot of new solutions in Copenhagen. Our bicycle infrastructure is world famous because today 62% of the Copenhageners use the bike for daily transportation.
Everyone in Copenhagen bikes, and I mean everyone. So the city is leaning into that. In the last 10 years, it has invested nearly $300 million to improve biking infrastructure. All that money is paid off. There are more than 5 times the amount of bikes than cars in the city. That goes a long way when cutting down on carbon emissions. But the effort doesn't stop there. Copenhagen has totally transformed their waterways too. Only a few decades ago, the harbor was contaminated with industrial waste, oil spills, even dead fish.
When I moved to Copenhagen back in 1987, this harbor was so polluted. You could never dream to have a swim in this harbor. But today you can swim. We have a harbor bath where people can have a swim with their kids after school or after job.
Though Copenhagen has made huge strides with their mobility and pollution efforts, by far their biggest focus is on energy use. It makes up about 80% of their carbon neutral plan. To cut down on their consumption, Copenhagen uses one of the world's largest and most successful district heating systems. It works by using a network of pipes to capture leftover heat from electricity production, then delivers that heat to homes across the city.
99% of all households in Copenhagen are linked to our very efficient district heating system. We have also introduced district cooling, where we take the cold out of the water in the harbor and distribute cold in pipes beside the district heating pipes. So you can reduce temperature in buildings, in server rooms, in factories. We can reduce electricity use for cooling down buildings with 70%.
To come up with these kinds of sustainable solutions, Copenhagen collaborates with partners across the city, like Copenhagen Solutions Lab, an incubator for smart city initiatives.
What Copenhagen Solutions Lab does is actually solving some of the bigger problems in the world by using technologies in order to accelerate this transition into a carbon-free economy. So for instance, the problem of air quality. People in cities are dying too early because of bad air, and that is a global problem, not just here in Copenhagen. Getting rid of our waste, measuring air quality, managing traffic. We're trying to solve these problems down in Street Lab.
Contrary to how it sounds, the Street Lab really isn't a laboratory. It's a 2-kilometer-long chunk of downtown Copenhagen that serves as a testing area.
Placing a lab such as this downtown in a real urban environment makes it very realistic. Everything we're testing here will be able to survive in other parts of the city and will be able to be scaled to a citywide level. This is a new generation of technology that makes it possible to measure air quality by a sensor. And now we're looking into mounting sensors actually on a Google Street View car to make it possible to measure each and every street of Copenhagen.
With these sensors, the city can better locate the source of pollutants to help improve overall air quality. The technology has already proved so useful that Marius and his team are shipping sensors to countries like Norway, Mexico, Austria, Greece, and the US. Though Copenhagen is leading the way in sustainable smart city solutions, experts and policymakers will tell you that the true secret to the city's transformation is the people. The residents here actually want to help build a sustainable city and are willing to work for it.
The citizens of Copenhagen, they demand a high quality of urban life. They are willing to do a lot themselves. They want to sort their own garbage. They want to bike to work. Citizens' involvement is key to the way we think in Denmark and in the Nordic countries. And that's a huge driving force behind being a carbon neutral city by 2025.
Since I became mayor in 2010, we have a growth rate in the number of citizens with 20%. And even that, we have cut our emissions with 42% in the same period. So we show that you can have growth, green transformation, if you do the right investments in the city.
Copenhagen's transformation hasn't been easy. And of course, their size and wealth helps. But they've made it work for their city. Regardless if they hit their carbon neutral deadline, their ultimate goal is to serve as an example for cities everywhere.
The green transformation of cities and livability, and also, very important, good economy goes hand in hand. I see Copenhagen as a front runner to show for my colleagues and decision makers, you must go green.
Thanks for watching. If you enjoyed our series about the future of cities,
Okay, so that was a great example of the green cities and how it could change using the Sustainable Development Goals. So, and coming back, how we actually got there to these making industrialization to net zero, and again coming back to the Industrial Revolution. So, basic requirements for industrial revolutions. To make big change in the economy, it is important to get ready all three groups of factors: materials, energy, information, and teamwork. They all need to work together as follow the same goal for the change to happen. So the journey toward the green economy brings about an inevitable and a far-reaching transformation in society. These transformative challenges are currently being addressed by what we refer as to third and fourth industrial revolution, often identified as Industry 3.0 or 4.0. At the center of society is economy, a crucial area that managers that complete task of making and using goods. As a result, it depends on a lot of basic technologies for creating things to getting energy. The third industrial revolution is a significant change in how society and the economy work. It includes a move toward using renewable energy and sustainable materials, the widespread use and new technology, the creation of connected production system, a digital way to collect and send information, the development of relationship where production and consumption are more equal, and the growth of supportive energy system. So the fourth industrial revolution bring an idea of computerizing system into product and consumption. This means fully automatic network that works without people having to do things directly. So we can understand this definition better when we look closely to the parts that makes up this industrial revolution. During the first industrial revolution, also known as a Great Industrial Revolution, which is typically dated approximately 1770s or 1860s, materials energy group of factors played a leading role in transformative progress. The primary focus was on transitioning from manual labor to machinery. So the key phenomena of the first industrial revolution actually include the spinning machines by Richard Ackworth that was created in 1769, which facilitated manual labor in a productive and canton trade. The use of a James Watt steam engine, we have some picture here, the steam engine in 1775 for tasks like water pumping in mines, an industry where hydraulic energy was not feasible. The implementation of Henry cord cutting process in metallurgy in 1783 or 84, allowing the substitution the wood charcoal with a coal coke as a energy source in productive in a production or wrought and cast iron. So we can see that key breakdowns of the first industrial revolution were indirectly or directly related to solving energy-related problems. Another was the need of increasing the power of labor tools, achieving the introduction of introducing the steam engine and empowering the energy sources such as wood and coal. The third addressed the storage of energy resource caused by deforestation in Europe. So this industrial revolution also addressed other issues related to modernization, the material basis of society. Metal replaced wood, and the primary building and constructing materials significantly increased and straight of the products and their ability to withstand higher loads. Another reason of the for the first industrial revolution was accumulating of a critical mass of capture in Europe, particularly in England, due to the potential of its colonies. And this capital served as a grassy energy resources for financing and the necessary technological and economical transformation. Those the prerequisites on a first industrial revolution driven by a need for a change in a source of paradigm, particularly the deficiencies of labor and energy sources like wood, as well as the opportunities created by accumulating capital, had a material energy nature. Material factors were essentially essential in generating impulses for transformation on the other two groups of factor, namely the informational and synergetic factors. Second industrial revolution. So the second industrial revolution and the development of industrial society saw the steam engine was ignited during the first industrial revolution, gradually gaining momentum and entering entering the 19th century. It became clear that for its further development and advancement, not only the adequate supply on energy carriers, but also different kind of fuel was needed. So industrial factory monsters, which had grown in sizes and require energy capabilities, but lacked coordination, began to suffocate without new informational ideas. These ideas became vital for improving manufacturing equipment, increasing the precision, enhancing product quality, and unifying the scattered product capacities in a single systematic entity that spanned vast distance, from raw material sources to customer network, material energetic factors. So what else were invented? The development of transportation and communication network also stimulated a growth of systematic factors. The industrial potential of factors increased, demanding the development of transportation infrastructure. So railways, canals. On the one hand, for the supply of raw materials, on the other hand, for distribution of finished products. This also drove the need to further means of communication, such as telegraph. Let me see. In second industrial revolution, which began in 1860s, information became the driving force of transformation. The development of the economy became increasingly reliant on scientific achievement, rather than just successfully inventions. Processes for obtaining metals, metalworking improved, the machines building progresses, production process started to be based on artificial chemicals and also physical phenomena, such as synthetics of new substances as utilizing for those already in use, new manufacturing technologies, new principles for engineers, and models of transportation, electrification of product, progress, and more. Certainly, the development information component influenced the material, energetic, and synergetic factors. Let me see if we're here. So material, energetic, and synergetic factors as well. New methods for obtaining and utilizing energy, new materials energy. Transportation means emerge. Communication also became more sophisticated. So, new conditions of product require new knowledge, worldwide and intellectual skills applicable most workers. The profession often referred to as a white collar, engineers, technical workers, clerk, managers, became widespread. The need of general literacy, the utilizing a new management methods, and application of specific techniques to influence worker. Their organization, motivation, and work emerged. So thus it can be argued that a second industrial revolution not only lead to the creation of new technologies such as machine tools with the numeral control, flow, production, electricity, telephone, radio, automobile, and aviation, but also had an impact on a creation a new type of labor force, mass worker, for whom metal work became a priority. It can be considered that the prerequisites of the necessity of the coarse transformation processes of the second industrial revolution began to be determined by the needs of intellectualization labor human, who at the same time transform into mass consumption in a market. The increasingly income of these customers became perform the function of capital. These created the conditions for sufficiency in the development in industrial society. However, by the second half of the 20th century, the possibilities of the industrial society began to be exhausted. Do we have a picture here? Yes. Facing severe constraint of the impact in natural environment, the colossus material intensity and energy consumption of economic system, global scale of the product complex against the backdrop of the planet pollution growth, turned out to the incompatible with the real possibility of restoring local ecosystem and the biosphere as a whole. So moreover, the main problem was, unlike the first industrial revolution, not the stage of natural sources. Industrial technological base coped with it, including the replacement of some primary materials, sources with others. It proved much more difficult to solve the problem of degradation to local ecosystem and the biosphere as a whole. And natural system ensured the formal of the planet assimilation potential of maintain Earth's energy system from destruction due to human overproductive of energy. And this leads us to the third part, and which is the third industrial revolution. So the already mentioned and other conditions, due to the limited scope of these sections, we cannot discuss them in details, but it could be resolved without the framework of 20th century industrial society, were intended to be addressed by the third industrial revolution. Its main component, digital technologies, mass computerization, and population network, originated during the final wave of the industrial transformation in the second industrial revolution, called TIR or TIR, and second industrial revolution, SIR, which is SIR. So the main objectives TIR fundamentally differ from those of the predecessors, the first and third industrial and second industrial revolution. During the first, especially the second, humanities thought to increase materials, energy, competing with the natural forces. It is enough to note that in 1950s, the slogan in many countries was "Everything big is beautiful." But for TIR, different goal was historically set: to return to harmony with nature through the transformation of production system, ecologization of social structure, style changes, and ecologically detected transformation of the individuals. In such condition, the focus should not be on increasing scale, capacity, and form of social production, but rather on their minimalization, often accompanied by increased productivity, enhanced function capacities, and improved sufficiency of the economy system. As the two previous industrial revolution, all three groups of system forming factors of the economy: material, energy, information, and synergetic, undergo transformation in TIR. However, at the current stage, leadership in transformation processing shifted to synergetic factor. They are tagged with integrating individual components of local economical system into unfilled systematic, a whole global economy of the spaceship Earth, akin to how integration process occur in nature, where individual local system, when combined, form for planets and biosphere. Okay. No, actually, we hear, yes. So the fact that the course of the industrial third revolution, the driving force of the transformation became synergetic factors can be explained by objective reasons, and there is 4 reasons. So firstly is the production sector, the center of gravity, basically. Shift from large economic forms, powerful regional power plants, industrial giants, massive processing, and resources of small productive units. They can become a real productive force only when united into cohesive system. The examples, it's IT enterprises, mini power factories that use 3D printers or productions or machines. Secondly, it's the reality of transformational virtual production activities has emerged, which can functionally only at the basis of advanced synergetic connections. The third one, the operation of computers. Informational control systems such as smart factories, smart homes, smart cities, smart transformation network, the smart countries, inconveyable without the analytical and integrating influence of information network, primary, the internet. And fourthly, the internet itself, as a fundamental factor of humanity, global memories, is a product of energetic of local information system. So this is a great slide of explanation of how fast the evolution, third one, right? The third evolution actually we're going. We see on a 50 years, it's a huge jump with the technologies. For example, in the middle of 2017, the number of regular internet users exceed 4 billion people, particularly surpassing half of the Earth's population. Since 2000, the percentage of internet use has increased 8-fold, from 5.6% to 54% in Europe, only in Europe. Internet penetration reached 75% in North and South America, and 66%, and it was 66%. In a country like Norway, the United Kingdom, Qatar, Japan, and IOA is exceeded on 90%. So almost everyone using internet. This is like impossible to imagine that there is no internet around. So the number of mobile phones connection is in 2016 reached 8 billion, surprising the world population. Currently, 2/3 of the Earth's population use mobile phones, with many having 2 or even more. Although 1/2 of the Africa population owns mobile devices. E-commerce account for nearly 20% of global sales volume, reaching 1.5 trillion by the end of 2017, which is a little bit old information, but you can double it on 3 times. So the transition from 20s to the 21st century should be considered the beginning of the third industrial revolution, when 3 key inventions of humanity merge into single whole: the World Wide Web, the person computer, the internet, the digital technologies. These innovations facilitated the explosive progress on social relationship and technologies, including technology transfer, since the speed of the development of any system, especially socio-economic ones, is determined by the characteristics of their speed, which is efficiency. Okay, let's be here a little bit. So one of the another task for TAR is called upon to solve is changing the imperable of shaping the essential principles of human being. Specifically, the economy must transition from saving predominantly the material needs to the sociological and economical nature of human being. Okay, so the main backgrounds, let me double check here. Okay, the main backgrounds of TIR revolved around ensuring affordability and efficiency of the following area. It's obtaining renewable energy, energy storage, manufacturing and operating 3D printers, computing, processing, transforming information, numerous publication corroborative these advancements. Since 1970, the cost of production solar energy has decreased by a factor of 150. The predicted converged the prices between traditional and alternative energies sources for 2021 was actually achieved as early as 2015. New reports have related the possibility of significant reduction in the cost of 3D printing. For instance, such a device may cost no more than refrigerator, about $180. Today, technology have become so cost effective that, for instance, the production of sensors for RFID tags has reached the level of affordability just in $1. So this pivotal development has paved the way for their widespread applications and marked the beginning of the fourth industrial revolution, which is primarily characterized by machine-based identification of physical objects. The establishment of these prerequisites has created a solid foundation for addressing several particular tasks. Transformation of the economy during Third Industrial Revolution. And let's see, how much time do we have? I think we can cover today the main one, the Fourth Industrial Revolution that we are actually in right now. but it's also depend on the country. Some country already moved forward and they are quite far on a progress, and less developed country are still on a fourth industrial revolution. And there is no possibility to go forward to industrial revolution number 5 unless you go through the whole steps or industrial revolution 4. So what is it? The fourth industrial revolution, also known as a 4.0, logically continues as a trajectory of the third one, in which the synergetic foundations serve the driving force for the development and socio-economical system. The issue of fourth industrial revolution gained significant attention after presentation at the International Environmental Forum in Davos in 2016 by one of the leading territories of the Industry 0.4 phenomena in Swiss. So Swiss economist Klaus Schwab, he characterized this phenomenon as a blurring of boundaries between physical, digital, and biological sphere. The concept of fourth industrial revolution was initially formulated as a Hanover Fair in 2011, where it was defined as an implementation of cyber-physical system into production progresses. Germany has taken the lead in the fourth industrial revolution with its Industry 4 program. Within this framework, major German corporation supported by rich grants for the federal government are creating fully automatic production facilities. These facilities involve interactions between production lines and production themselves, as well as interaction with the customers, all within the framework of Internet of Things. And we're going to talk about it, I think. Let me double check. Yeah, we're going to talk about it just a few slides after. The Internet of Things, please remember this. This enabled the production of personalization good. Cyber physical systems are expected to be integrated into single network, forming local ecosystem that functionally serve specific buildings, enterprises, or even cities. This unification of artificial technical system into comprehensive global network or system is reminiscent of biosphere that utilize the planet living world. The key functions that this cyber physical system should perform without human intervention include real-time information exchange between themselves, akin to communication, monitoring or external environmental parameters and their own conditions, self-activation and shutdown basis on a specific information signals, self-adjustment of optimal operation models, predictive self-serving of systems, interaction with the products they produce, adaptation to new customer needs, determination to equipment need to produce necessary good or satisfy new requirements, self-learning, which is great. They are learning so fast lately. There's just a few days ago, there's a robot. They created a brain using the real brain cells instead of artificial technological one. And those brain cells was 5 times faster and smarter than artificial intelligence. and they teach, I think in a day or half an hour, I'm not exactly remember, they teach a robot to play tennis based on our human cells connected to the technology. This is insane. And they self-learning how to walk, how to talk. Incredible. So, for example, in the smart homes, individuals can remotely control doors, lighting. We have all, not all, but some of them maybe have this Xiaomi or any other smart home solutions to turn off, lighting, vacuum cleaners, monitor home security via smartphones. However, a truly smart home will be capable of autonomous action, such as closing windows during adverse weather conditions, like when it's rain, it's going to analyze what is there and then close your door based on your decision if you want it or not, and opening them also, whether it's hot, provided user giant permission through a program. So the Internet of Things, IoT. The Internet of Things should be the primary outcome of the fourth industrial revolution. The IoT concept involves a computating network and physical object, thing, equipped with embedded technologies for interaction among themselves or with internal environment. Such as interaction to occur partially or entirely without human involvement, without at all. It is anticipated that organizations such as a network lead to transformational of economic or social progress, promoting human social development. The main application areas of the Internet Things are devastated. So communication between actually let me come back here, just add you a little bit more. So furthermore, a system equipped with artificial intelligence can assist in decision making, such as sensing, the conforming and purpose decisioning to available sources in enterprises or within the legal framework of the country. Communication between humans and objects, they use it, another aspect of IoT. Clothing, shoes, watches, mobile phone, everything a person carries can, thought feedback, become subject of optimization and enhancing capacity in the pair of the IoT. And in conclusion, the first industrial revolution hold the promise of the comprehensive network that revolutionizing communication creates synergetic between various elements of society and empowers human process in unprecedented ways. So here we're coming to communication between machines and things. So we know how machines can communicate with us, like a phone and others, right? But what about between machines and things? Communication between machines, also called M2M, you can see it here, right here on the middle, also goes along with the IoT. Translating like also things with a thing. I mean, thing with a thing. Things with the machines. Solves a wide range of tasks through a system of feedback. Along the most important of these are. So it's increasing the efficiency of productive and operating of things. It's improving customer properties of goods and establishing communication between customers and producers, and also environmental improvement in production and consumptions of goods. Additionally, the fourth industrial revolution has significant impact of interaction among humans. Let me see what we have here. Yeah, the interactions. Changes in relationship among industrial due to the technological change brought by fourth industrial revolution in technical sphere and human living environment. The enhancement of the sociological resilience in individuals and the development of teamwork skill are key goals of fourth industrial revolution, and also improvement of the toolkit for interpersonal communication, for example, including business ethics and cross-cultural relations, plays a significant role in the social changes driven by fourth industrial revolution. And let's see, yeah. So other information, important aspects to consider in this context include the individual relationship with a society with a high relevant as a leisure time increased, the people well-being improved. Society relationship with individual, where one option is the deletable influence of society of shape individual qualities ready for social development in an informational society and under several ecological constants. The fourth industrial revolution can also impact the environmental shape positively. The Industry 4.0 can help close resources usage loop and transform the economy into more sustainable one, reducing the ecological footprint, for example, on the planet. However, fourth industrial revolution carries social risks, such as displacement of individuals from economic processes and loss of the jobs. We don't need to go too far. There's almost, I think, about half a year ago, the well-known company McKinsey, I think there was a McKinsey consulting company. They, when the GPT chat was launched to the public, they fired, I think, about 60,000 people or 30,000. Well, this is basically a half of their office. So they said that this is not related to an artificial intelligence that was there, but it was clearly showed that it was. The artificial intelligence can do same analyzing process that the human do, even better right now, and we're going to talk about that also in the next lectures. But right now, the artificial intelligence can pass the Harvard law test, same as a student, even better, and it's improving itself every day, like every day, not even weeks or months, like every single day, it's improving itself, which is literally very crazy and interesting. So yeah, the risk it's a loss of the jobs is such a condition. It is essentially to ensure that jobless does not lead to social stagnation, but instead contributes to social development, which is good. Those four industrial revolution has also potential to bring significant benefits, but it also presents the potential of significant challenges that require careful attention and management. And this is the end for today's lecture. we're going to continue fifth industrial revolution on the next class. On Tuesday. I hope you enjoyed this lecture and you did like it. Hope the information was helpful and interesting. Does anyone have maybe question? Sounds like no. Okay. Does
I don't. Sorry for interrupting you. I don't have a question, but I wanted to say very thank you for all this information. Useful. It's really great. A pleasure listening you.
Yeah, well, I know it could be a little bit too much for today. The whole three industrial revolution in one hour. But I think this is just shows you how the progress where we, where it leads us. And from this point of industrial revolution, we're going to be more focused on digitalization. And the artificial intelligence, and also tourism, how we can use that artificial intelligence in tourism. Because as you see here in Industrial Revolution 4, it clearly mentioned that we're going to be surrounded by technology, robots, 3D printers. And our goal basically as a society is actually learn as soon as we can, as fast as we can. And instead of they will manage us, we should manage them. So this is quite tough question and topic. But thank you so much that you all listen. See you on Tuesday. Happy to see you here again.
Thank you. See you.
Bye-bye.
Oh, det är